Let's say we're headed out to visit an abstract art exhibit at a museum. Maybe we know a thing or two about art, or maybe we're just budding enthusiasts. Either way, we might find ourselves coming up with interpretations that are wildly different from what the artist intended. Like on our own, we might be staring at a painting and see fish swimming in the ocean when it's supposed to be a summer day in Italy. We need things like signposts that give us some clue of what the artist was trying to tell us. And the same is true when it comes to large amounts of data. Fortunately, tools like measures of central tendency are those helpful signposts that can help us understand what the data is trying to tell us and come up with even deeper insights. I'm Jason Guglielmo, and this is Study Hall Real World College Math. If we think about our data as the noun, the main object or focus of a sentence, then the measures of central tendency and the data visualization techniques we explored last episode are the adjectives. They give us new ways to describe the data, and they spruce up the data to give it some more flair and color. To see what I mean, let's take a look at our friends Alina and Harrison, who both dream of becoming professional soccer players in the US. Today, Alina and Harrison are playing a game of pickup soccer. While taking a break, Alina gets a notification on her phone about the salaries of the top 10 soccer players in the US. She mentions it to Harrison, who says he saw a similar list a few days ago. He did some of his own calculations with the numbers, sketched some supporting visuals, and he was in disbelief at how relatively low the pay was, considering they're professional athletes. Alina is looking through the list now, and she notices that some of the players on the list were earning about $35 million, while others were making more than $90 million. She wonders how Harrison could be this greedy. Ultimately ignoring Harrison's conclusion, Alina thinks to herself that if she keeps her practice up and plays just as good as any of these pro athletes, then hypothetically she should be able to earn the same amount someday and play in crowd-filled stadiums. But looking at the list alone, the numbers are sort of all over the place, and it's not very clear what's typical or what's like the Beyonce level paycheck. This is where the measures of central tendency come in to give her some tools to describe what's at the center of this set and what a typical elite player might expect. When Alina looked at the list, the first thing she noticed was that some of the players on the list earned $35 million. 2 to be exact. That means 35 million is the value that appears most frequently in the dataset, or the mode of these salaries. And one way to think about what's typical is thinking about what happens the most often in a set of data. But sometimes there's more than one mode, or no mode at all. So for some data, the mode isn't always that dependable. And in Alina's case, with just 2 out of the 10 players making $35 million, she feels like there's more to explore. Like, imagine we wanted to balance out all of the salaries so that everyone got paid the same amount. We could pool all the money together and give each player an equal share. She pulls out her phone calculator and adds up all the salaries and divides by the number of players to get $57.9 million. This is what each player would earn if we kept the total amount of money the same, but they all had the same salary. In fact, this calculation that Alina did is called the mean, which you might have also heard called the average. And we can use her process to come up with a general formula for the mean. Whatever the scenario, first we need to add everything up to find out how much we have total. Written in math notation, we can take our set of data points and label them x sub 1, x sub 2, and so on up to x sub n, where n is the total number of data points we have. Then we need to split the total between the data points, like Alina divided the salaries between the players. And ta-da! We have a general formula for finding the mean. So Alina figures that if she can play as good as these top pros, then her typical salary could be around $57.9 million. But Alina also noticed that no one on that top 10 list makes anything super close to $57 million. They're all well above or below. In fact, the majority of the players make less than $44 million, which makes her think that the mean she found tells her some things, but that it still might not be the best representation of a typical salary and the center of the data. When she looks closely, there are 3 players that make so much more than the other 7 on the list. They are outliers from the rest of the data, which skews the mean or pulls it in a certain direction. This skewing is what can make the mean unreliable and untrustworthy. In math, we call that not being very robust to outliers. But never fear. Not all measures of central tendency are as sensitive to outliers or skewed data. Now, Alina opens her Notes app and orders the salaries from least to greatest, hoping that the number in the middle of her data can tell her something about how much she could get paid. The measure of central tendency she's finding now is called the median, and it's literally the number that falls in the middle of the dataset. So if Alina had 9 data points, then the median would just be whatever value is 5th in line. because there are 4 values before and after the 5th spot. Or if Alina had 11 data points, then the median would be whatever value is 6th in line because there are 5 values before and after the 6th spot. In general, when we have an odd number of data points, the median is the data point exactly in the middle. Or in math lingo, if you have n data points where n is odd, then the median is always the number in the n+1 divided by 2th place. But if we have an even number of data points, like in Alina's case with 10 salaries, then the median isn't one of the data points. Instead, it's exactly halfway between the 2 middle data points. When ordered from least to greatest, the 2 middle numbers on the list of the top 10 soccer players' salaries are $35 million and $41 million. So the median salary for the top 10 soccer players is $41 million plus $35 million divided by 2. Which is $38 million. So the median literally splits your dataset in half no matter what values we're working with. Looking at only the values that are less than the median, Alina can see the lower end of her earning potential. And only looking at the values greater than the median, she can see how much she could make on the higher end. But we can go even further and break the data up into quartiles, or 4 sections. Looking at the 5 values that are less than the median, we can find the first quartile, or lower quartile, using the same process we used to find the median. Since this subset has 5 data points, which is odd, the first quartile is whatever the third number is in this subset, which is $34 million. So $34 million is the first quartile. Then the second quartile is just the median, so we're all set there. And looking at the subset of data points that are greater than the median, we can use the same median finding process again to find the third quartile or upper quartile. Again, we have 5 points, so we want the salary that's third in this list, or 8th in the list overall. That makes the third quartile $95 million. Between the first quartile and third quartile is 50% of the data. So half of the players are making anywhere from $34 million to $95 million. This is a pretty big spread. Alina tells Harrison he must be crazy to think that either of their skill sets aren't worthy of being within any of these quartile sets. She even draws her findings for him. She says, the lowest they earned was $29 million, and at the highest they earned $125 million. Both very large numbers, by the way. Then the median is $38 million, which splits the data, and the first quartile is only a little to the left of that at $34 million. Now the third quartile is rather far away at $95 million, but squeezed in between the third and first quartile is where all of the earning potential is if we want to ignore outliers, like those 3 players who make over $90 million. After all, the range between the first and third quartiles represents 50% of the salaries. In fact, the area that Alina is emphasizing is called the interquartile range, which is a measure of how much the data points vary, which we'll talk more about in the next episode. And we can give it a value by taking the third quartile minus the first quartile. Here we get $61 million. What Alina has drawn here is known as a box and whisker plot, also known as a box plot. Box plots help give us a way to look at the 5-number summary, which is the minimum, maximum, and all 3 quartiles of a dataset. It's always helpful to have a scale at the bottom, and in Alina's plot, she used a scale with increments of $15 million. But Harrison stares at Alina's plot in utter disbelief. And instead of saying anything, he just shows her the visual he made from the data he looked at. Their starkly different box and whisker plots summarizing their quartile calculations can only point towards one thing. They were never looking at the same list. Alina's dataset contained the top 10 highest paid men's soccer players from last year, while Harrison's list was the top 10 highest paid women's soccer players from the same year. They both used the same measures of central tendency and calculations, but their data points were not the same. Alina and Harrison see very clearly that women in soccer get paid dramatically less than men. The measures of central tendency added some more character to that data because now they can see the differences in their average pay, median pay, and by putting plots side by side, they see the overall inequity in pay by gender. The mode, mean, and median might seem like deceptively simple calculations, but they help us describe or summarize data in ways that large sets of numbers or individual points just can't. In fact, using mathematical information like what Alina and Harrison calculated and combining it with testimonies from actual players, in 2022, the US Soccer Federation announced that both teams will now be paid equally. Like we said at the start, data sets can be like abstract art, and measures of central tendency act as signposts that describe a group of data points. Those signposts help us interpret what the overall data is trying to tell us, and sometimes it's a way to seek and enact impactful change, like closing gender pay gaps in professional sports. Of course, there are more tools that can help us interpret the art of data analysis. So in our next episode, we'll expand our toolbox and talk about how data is dispersed. Thanks for watching Study Hall Real World College Math, which is produced by Arizona State University and the Crash Course team at Complexly. If you like this video, give us a like and subscribe. You can learn more about ASU and the videos produced by Crash Course in the links in the description. See you next time.